and really pinpoint how you can achieve those behaviors. And one sort of very popular methodology is the 12-factor app methodology, because it is platform, tool, and language agnostic. So really this can be applied to pretty much any application. And if you've not seen it before, then head on over to the 12factor.net website, and it goes through each of the factors in a lot more detail. I put the link there at the bottom if anyone's struggling with that. But essentially, this is what the original 12 factors were. And it's got some fantastic starting points when you're looking at trying to create a cloud-native application. However, this was written originally by the Heroku developers. It's kind of since been adopted by the community. This was written about a decade ago. So although these are a fantastic starting point, technology and our cloud infrastructure has moved on since then. And so these factors sort of needed a bit of updating, and there were certain elements missing from this original list. Like, for example, security, which I don't think I need to point out, given the Log4j incidents that have been going on recently, how important security is for cloud-native applications. So this was essentially revised by a guy called David Hoffman. You can Google his book, which is sort of Thriving in the Cloud, and it's free online if you want to check out the originality of where this 15 factors has come from. But these 15 factors have essentially taken the original 12, edited them slightly to make them more specific, and they've also added in an additional 3 factors.
So you have to go to the next slide. I'm going to quiz you all to see if you realise which additional factors.
I made it real easy, I've highlighted them. So so these are the sort of factors that we're going to be focusing on today. If you're interested in any of the other factors that we don't cover from the original 12, then there's an article that I'll link to in a minute that I've written on IBM Developer, which links off to each correlated lab that we have. So if one piques your interest that we don't cover, you can visit that article and find out which lab and which technologies you can try to be able to achieve that characteristic or that factor. You can notice that there are slight changes, for those of you who are keen-eyed, or perhaps just know the 12 factors. There are some changes to the original factors, like for example, when we have one code base, one application, that was originally just code base. So they've tried to add more specificity here, saying, for your application, you should really have one code base, but you might have many deployments of that in various different environments, but they should originally come from that one code base. There's also changes like environmental parity. In the original 12 factors, that was dev-prod parity. But actually, as developers, we know we don't just have development and production environments. We have a variety of different environments, including things like testing and QA. So it's about making sure that all of those environments have this parity, this similarity in the backing services and the tools that you're using to ensure that you don't have unexpected errors when you push your app into production. So there are changes that have been made. They are slight to those original 12 factors, and the technologies that you can use for them are pretty much the same, which is why we're just going to focus on the new 3 factors that we've added. So those are API first, telemetry, and authentication and authorization, that security element that I was talking about before. And actually, by following these 15 factors, we can start to achieve those characteristics that are part of being cloud native. So if we start looking at sort of a generic instance of an application, this arrow here is meant to represent the development lifecycle, sort of the process of creating an application. And when we start to map out the 15 factors, we can start to see how they affect the various elements of application design and development, and we can start to map out where those key characteristics that we're trying to achieve come into play and which factors can influence those. So if you're particularly interested in one particular behavior, you can maybe narrow down and focus on that factor that's related. And that's how we can start to achieve all of the benefits that we want from our applications. And there are lots of different tools that we can use to achieve that, many of which are open source, and we're going to be delving into some of those open source, specifically Java tools, within this presentation. So without further ado, we're going to delve into those. We're going to give you a brief introduction to what those tools are before we actually get into using them ourselves.
There you go. Alright, so like Grace mentioned, the world has changed a lot. Before, I'd say 20 years ago, it was very difficult to try out a lot of new stuff, but the open source community is crazy nowadays. There's so much out there. And one of the things we're going to talk about is Open Liberty. So this is the project me and Grace work on at IBM. So hands up, anyone heard of Open Liberty before?
Oh, nice.
Nice, got a few people. Awesome. Shane, yeah, you cheated. So Open Liberty is about to have its 5th birthday in September, I think.
It is, yeah.
So this was open source, like I said, about 5 years ago. This was open source with the IBM Java, which is OpenJ9. And this was, I think, IBM's biggest open source contribution in history. I think it was around 10 million lines of code or something ridiculous like that. So what have we tried to do? What is Open Liberty? Well, essentially it's a Java runtime, so where you would run your application. And traditionally, what we try to do, the days have changed where organizations, executives will sell an organization some technology and then the developers have to use it. Nowadays, developers, you all have a lot more say in the technology you use. So we wanted to make something that was actually nice for developers to use and they wanted to use it. So first of all, we've tried to focus on code as much as possible. Again, developers shouldn't have to worry about the runtime side of things. They should be able to create their code and just deploy it. So that's what we've tried to focus on here. Easy to make fast and iterative changes, so I'll talk a little bit about that in a moment, but essentially every time you make a change you don't want to have to rebuild your runtime, so trying to make that as easy as possible. We've tried to make it really easy to run tests. So there's things called test containers. Hands up, anyone heard of test containers? If you haven't, you should definitely check it out because it's an amazing open source project. So supporting things like that to make our lives a bit easier as developers. So the first thing I worked on when I started my career at IBM was I joined the team and basic Docker had just become a thing, and they turned around and said, right, you need to containerize this. So out of university, I had no idea what a Docker container was. So we were one of the first products in IBM to actually be containerized. And because of that, we have really optimized our application, our runtime to work with containers and Kubernetes, etc. And with tools, we don't want tools that are in your way. You have the ability to use them. We support most of the IDEs, but really it's kind of up to you what you do. So this is kind of where we go back to making very quick and fast changes. So we have something called dev mode, and this kind of takes the pain away from you having to worry about the runtime too much when you're developing stuff, because at the end of the day, I'm a developer, I just want to create my code and I just want to run it. And what this allows you to do, essentially you start the runtime and it will pick up any changes you make instantly. So you don't have to worry about starting the runtime and things like that. It will just launch those changes in milliseconds, and by the time you've got back to your browser or whatever you're trying to test, those changes will have already taken effect, which is awesome. So it takes a bit of the pain away from developers having to worry about the runtime. It also works with testing as well, but we don't rerun our whole load of tests every time we make a small change, because that can be a very big suite of tests. So you simply just go back to the terminal, hit enter, and it will rerun your tests again. So we don't want big runtimes anymore. We want them to be as small as possible, because of course we're now renting hardware on the cloud, so we need to be as efficient as possible with what we're deploying. And essentially this is a modular runtime, so you kind of start with the smallest amount you can, and then you add in the functionality you want, and that hopefully brings down your size on the cloud and the containers you're using. So we have always tried to be very quick to certify for a lot of things first. This slide needs a little bit of updating, but I think we were the first to certify for Jakarta EE 9, if I'm not correct. Yeah, we've generally been the first to deliver MicroProfile, and there's a 4 and a 5 version now. So we've really tried to be at the forefront of certifying for any of these new technologies. And the reason is because we're in an agile world and we kind of want to take advantage of all these new technologies. We don't want to wait years before we move up a version, etc. So we've always tried to be the first to kind of deliver these things. And trust me, it is quite painful. You see all the development teams stressing because a thing has come out and we've got a deadline to get it all certified. Again, development productivity is kind of at the heart of what we do, so we try and support all the main things. We have our tools and the main IDEs. You can use Maven and Gradle, and someone asked me the other day, yes, you can use Ant if you want, we do support that. So support the main APIs, so you have like MicroProfile, Java EE, Jakarta EE, and Spring Boot. Some people, if you're using Spring Boot, for example, a lot of people use Tomcat, but there are some great benefits of using Open Liberty with Spring Boot. I think we nearly have double the throughput that Tomcat has. So if you think about that on the cloud, hopefully you'll need half the microservices to do the same job if you've got double the throughput of the runtime you're using. So if you're not using MicroProfile, Jakarta EE or Java EE, etc., do try this out with Spring Boot. It's very easy to get started, and we do actually have a guide on the OpenLiberty.io website that shows you how to do that. And in terms of testing, I mentioned test containers. We have also our own framework as well called microshare testing, and that essentially takes some of the pain out of what you have, the setup you have to do with test containers. So recently I had to go through this microshed testing library and basically unengineer it to create what's going on under the covers. But honestly, microshed testing saves a lot of effort. It connects to Kafka connectors for you, it makes life a lot easier. So like I mentioned, we were one of the first IBM products we put in a container. This means we have optimized and optimized and optimized again for this kind of infrastructure. And we have something called the Open Liberty Operator. Now, who's heard of Kubernetes operators before? And you're all kind of bunch, you've heard about all these new technologies, it's awesome. Alright, okay, so we have a level 5 operator, and what that means, it helps you with things like managing the deployment, getting logs and things out of it. So basically, it abstracts a little. So MicroProfile, it's all good. MicroProfile is a specification for enterprise Java microservices. So when this was envisioned, there really wasn't any open source specifications for building microservices. So lots of companies all kind of got together, which I have here, to create this specification. And MicroProfile is amazing. It's really fast at what it does. One of the great things about MicroProfile is it's vendor neutral. So you're not locked into a single vendor. I can be with Open Liberty, I can use Helidon from Oracle, for example, I can use Pyara. They all have their own implementations, but it should make going to different vendors a lot easier. And also it's community driven and open source, so no one specific company is deciding where this specification goes, which could be a problem with Spring because it's specifically one company that's kind of controlling the direction. And the problem is, again, if you have to, and you're going to be trying to untangle a very big mess. So these are some of the specifications, but we also have standalone projects. So if you are using reactive architecture and things like that, there are the reactive streams operators, reactive messaging, and they work really well with the rest of the MicroProfile specifications. So I will now hand this back to you, and you can talk about the original 12 factors.
So as I mentioned, if you are interested in doing any of the guides that are specific to those original 12 factors, this is the article you want. So you can either just Google 12-factor article IBM, and it should pop up on Google, or we have a direct link here, ibm.biz/12-factor apps. So in this I go through each of the 12 factors and link them specifically to the guides that are applicable to those factors. We're not going to be covering them in this session today in the interest of time, but they will be up there for as long as I can think of because we don't plan on taking them down. So yeah, feel free to go and do that in your own time afterwards. But we're just going to be focusing on the additional 3 factors, and I'm going to be running through those now. And these are the labs that we're going to be focusing on in this workshop today. Today, in the interest of time. Oh, hear myself. It's like an echo. So this is the article. If you, for example, don't get around to one of the labs today and you want to go back to it, if you don't want to visit the presentation slides, you can just head straight to this article. Very similar to the 12-factor one, it's just this one focuses specifically on the additional 3 factors. So a bit of revision, if you want some revision after this session. So, moving on to the additional 3 factors. The first of those, as Jamie mentioned earlier, is API first. This factor, the important thing to think about with these factors is sometimes they don't necessarily relate to a physical requirement from your application. Sometimes they relate to more behavioral characteristics of the organizations and the people who are developing these applications. And this is one of them. So API first, this factor is all about putting the APIs first, as the name suggests. So really making it a first-class artifact in your delivery pipeline, essentially. So it's about making sure that you're thinking about, okay, what am I putting, how am I designing my API, firstly, in that design phase, and making sure that you're testing that, vetting that with stakeholders, ensuring that that API is clear without someone having to go into the internal workings of your microservice to know how they can connect with it. Because really what we're designing when we're designing applications is a participant in an ecosystem of microservices. Your microservice might be being consumed by someone completely different in, say, another part of your organization, or either in another organization entirely. So it's important that your APIs are really clear and easy to use, and that you're bearing in mind that design and the fact that your microservice is being accessed through that API. How can we do this? Well, there are lots of different open source specifications we can use to be able to create essentially a generic language that ensures that everyone can understand